we did last Friday?
Do we have notes out right now?
We had our parts labeled. We said R was 16, we said S was 30, and we said T was 34.
Yeah, we got part of it, guys. I think you started it.
And we're going to find the sign of R.
You only got the sign on mine.
Yep, you only got the sign. We'll review it just to refresh your memory. So remember, follow these steps to set up those ratios. Start at your angle. Well, we're dealing with angle R, so that's where we're going to start at. And then label your sides. So start at your angle, drag your pencil directly across. We said that was our what? Opposite. Then you start at the 90, go directly across. We said that was our what? Good. And the guy left over is always just our right? You should also have self-control written at the top of your paper. Go. Okay? Well, if we're trying to find sine, what two pieces do we need? What over what?
Opposite over.
Yeah, opposite over the hypotenuse. What's our opposite? 16. What's our hypotenuse? And what does that reduce to?
8 I thought that was working. I thought that was working. You went in here. Why do you know that?
Right? But you're going to do the same thing when finding the cosine of our oops, well, right after the word sine, make sure it's abbreviated. We abbreviate cosine with COS. So again, look at SOHCAHTOA. We're not going to rechange anything because we're dealing with the same angle. What over what gives us cosine? Adjacent over the hypotenuse. What is our adjacent side? Over what's our hypotenuse? And then always simplify down your fraction. What does 30 over 34 simplify down to? What? 16 over 17.
I told you that.
Question?
Oh, I went to angle S.
Okay, gotcha. Nope, we're still on angle R. We'll get to angle S here in a sec. Okay. Now we have to find the tangent. What's the ratio for tangent? What over what? Over adjacent. Well, what's our opposite side? What's our adjacent side? And then what does that simplify down to?
It don't.
Now we're going to repeat the same process, but with angle S. So that means you might have to cross them out. I'm going to erase, but our parts are moving around. Those measurements are going to stay the same, but some things are going to change around a little bit. Now we're starting at S. So go to your angle, and you need to relabel your sides. We start at our angle and go across. That's our what? Cross from your 90, that's going to stay your hypotenuse. Doesn't matter if you're dealing with R or S, that's always your hypotenuse. So the guy left over is your adjacent. So think if you did angle R, and then you have to do angle S, the opposite, the adjacent just flip-flop. Hypotenuse stays where it's at. Okay. So now we're going to find the sine of F.
I am right here.
Okay. Again, what over what gives us the sine? Over 8. So our opposite is now what? 30, and our hypotenuse is 34. Perfect. 30 over 34 simplifies down to? 15. Repeat the same process with the cosine of x. Again, cosine is?
Adjacent over.
Good. So what's that fraction going to look like? Adjacent is? Our hypotenuse is?
34.
What is 16 over 34 reduced down to? 8 over 7. And then you repeat the same process again for tangent. Again, tangent, look at so Toa is
This is the same.
opposite over adjacent, so we get opposite. Good, over 16. What does that reduce down to? Alright. You might be noticing some things. What did you notice about the sine of R and the cosine of S?
It's the same.
What did you notice about the cosine of R and the sine of S? And what did you notice happened to the tangents?
They switch.
They flip. We'll get into more in depth about the cosine and sine relationship Thursday. We'll go more in depth with that. I don't know if right now just kind of recognize that pattern.
All right, so now we're going to go into this next part. Probably, again, well, I told you, I like doing this trig stuff. It's nice and fun. This next one, probably the most fun of all. So let's try this out. Let's solve for unknown pieces and right triangles. Cool little method here. All right. It is really like a puzzle because you're doing the same patterns over and over again. You're trying to figure out what piece I'm missing and solving the unknown piece. Again, I know you guys have it on top of your paper, but some people don't. But the first thing you should always write at the top of your paper when you come in is going to be the SOHCAHTOA. SOHCAHTOA. Now the reason we do this is it helps me set up my ratios. So I know, well, what piece I'm missing, it determines this. So again, the process is the same. Watch what we do. Okay? First thing I need to do is I'm going to start with the angle. I never, ever start with a 90-degree angle, so it's always going to be one of the angles that's not 90 degrees. So what angle am I going to use in this case, in this scenario? Yeah, 54. It's the only one I have. So I'm going to circle it, because it's very important to me.
You could get the other one.
I could find this one too if I needed to. I could really just subtract 180, figure that too, but I need to start there because it's got to help me find for this missing side. Now, this right now, once I have the angle where I'm starting, I'm going to have to find and name the various pieces. So it's the same process we've been doing thus far. Go across, find the OPP, you know me. There it is. The next one's going to be your hypotenuse, is always in that cross at a right angle. HYP. And then the last one is going to be the ADJ. We always do that one last because it's sometimes hard to see where that adjacent one is at. Now, this is where we're going to go a little bit further and try to say, well, what pieces? Now I truly got to decide. So over here, we knew we were going to do all three of them. We knew it. This time we're only going to do one of them. But we got to figure out which one we're going to use. And that is determined by what sides or pieces that we have. We're always going to have two pieces that are marked, either with a variable or with a number. So look up here, what side, don't shout it out, raise your hand please, what side has either a variable and a number? Give you guys time to think about that for a second. Got it? See? What pieces? Either adjacent, hypotenuse, or opposite. Two of them. Megan, give me one of them.
You go.
The what? Can't hear it, so hypotenuse is listed. There's one, and the other one that has something listed on it, perhaps a variable, is the, yes, Katie? The adjacent, nothing up there on the adjacent. The opposite. So, we have two things. See how there's a W right there? That's what we're solving for. So we've got the opposite and hypotenuse. Which function deals with opposite and hypotenuse?
The S.
The sine, the S. So that tells us which one we're going to choose. So we're going to set that one up. So we're going to say sine of the angle, because that's where we always started. What angle did I start with?
54.
So sine 54 is equal to my ratio, opposite over hypotenuse.
W over 15.
W is my opposite. Hypotenuse is 17. Now, we're going to have to solve this, because we're trying to ultimately solve for what W is, that missing side.
Yep.
Now, look at this, thinking about your knowledge. What do you think I would do as my next step to solve to get W by itself? What would I have to do? Before you put your calculator, what is my step before I can do that? How would I solve an equation that looks like this?
Multiply.
Multiply by what?
W.
No, not multiply. I need to get W by itself. This is dividing by 17. So the opposite would be multiply by 17. Multiply by 17. There you go. So this. The 17s will cancel out. Now, this is where you can now type your calculator. Let's do a couple of things before we go on here. If you have a graphing calculator, please make sure it is out and it is in the appropriate mode. You don't need one. You'll be fine with this. What I want you to do is go to mode. Hit mode on your calculator. You're going to scroll 2 down. I believe 3 down. 3 down. There's going to be things that says rad or radian and degree. Make sure it's clicked onto degree.
How do I
If it
get
is,
there on this one?
hit enter. You don't need that. It's not a graphing calculator. It will stay like that, we say. Now, if you have science class, your science teacher might have you switch it back over, but for us, keep it in degree mode. Doesn't really change much, just certain angle things like that.
Science don't like this way.
Yeah, just hit enter, and it stays dark. Yep, second mode will let you out, and then you're good. Alright, so now type this in your calculator. Those of you with graphing calculators, TIs, graph it just like this. If you have a borrowed calculator, hold the brakes. You guys type that in as you see it. Everyone else, if you borrowed a calculator, this is where everyone in the room who borrows a calculator, this class is a large group. You must practice this skill. You have to do everything backwards. So if you're doing this, you're going to have to hit 54 sine times 17. So do it that way.
17.
So do 54 sine 17.
Why didn't we do sine 54 times 17?
Because that's not how you do this. It's got to work backwards. So
Why didn't we do
you have the answer. You have the answer. You have a question. You need help. You have to go in the exact order as it is. So you did 17, and then it's sine, and 54. That's for a borrowed calculator. You have a calculator, you can type it in. Your calculator set up. Sine times 17. Yep.
Oh, mine's broke.
You just have to do it over. Good, nice job. You do it exactly as you see it backwards.
I'm gonna do it first.
I'll do it first.
54
Yes.
sine
Let times.
17.
Okay. Okay, you say it twice. Just say it one time, you'll be fine. Alright, so when I do this, my W is going to approximately equal, because it says round and nearest 10. Sam, what'd you get? 13.75. Round that up to one decimal spot. 13.8. So you get approximately 13.8. Again, the nice thing about this is there are three different functions you can use, sine, cosine, or tangent. But the process for all three of these, you're only going to solve three ways. This is the first way. And I'm going to teach you these nice little sayings here. They're going to help you memorize this. Well, look where the W is at. It is the top of the fraction. It's in the numerator. So here's my phrase. All right? And this represents any variable. But, and they all rhyme. X up high. What do you think you have to do? X up high.
Y down low.
Multiply.
What?
So when X is up high, you are going to multiply that answer. X up high multiply? I don't know what your English teacher taught you. That's right. X up high multiply. I'd write that down because it's going to be the same process every single time you do this. So anytime the X is up high, I don't care if it's sine, cosine, or tangent, if the X is up high, whatever's on the bottom, you multiply both sides by. X up high multiply.
But that's a W.
Again, it just represents a variable. Can't have the same for every single problem we ever come across. Now, let's go on the next one here. The process is the same. Start at the angle. What's your angle?
33.
Let me start there. Circle my angle. Label my sides. The one that's over here, you know me. This one right here, my hypotenuse. That means the last one's the ADJ.
Yep, so go back up.
So everyone's got your paper too. You can see. Paper should have it at the top of the paper. So it can help you out. Now, I asked myself the question. Again, I have the sides labeled, started at my angle, label all the sides. Now I say, what two pieces do I have value for? Let's go around here. Thanks, Ross. Raise your hand. What two sides do I have values for? Adjacent, there's three sides. Two of them have markings on them. Which two sides? Well, look up here. Which one has either a number or variable on it? Adjacent and? Perfect. You did it. So we have adjacent and hypotenuse, so the ones that have values for. Which one of these deals with adjacent and hypotenuse?
C.
The cosine does. Cosine, adjacent over hypotenuse. So that's the one we're going to choose. So I'm going to say cosine of my angle is 33, is equal to that ratio, adjacent over hypotenuse. Adjacent is what? 4.5. And my hypotenuse in this case is W. Oh. Notice the location of the W.
Down low.
U down low, which is dividing, you're right, but I can't divide a number by a W. Technically, what you do is exactly the same thing you did over here. I'm going to multiply both sides by a W. Those W's will cancel out. Problem is I'd have a W cosine 33. Don't want that. Then I'd have to divide by cosine 33. I don't want to make you memorize that. So we're going to go right to what my saying is to help you memorize this. It's going to say X down low. You ready for this one? X down low. Switch a row. X down low, switch a row. I could have rhymed anything else. Sounds pretty sweet though. And what that means is this. Whatever is over here, X is, the unknown is down in the bottom, in the denominator. All I'm going to do is just switch those. And that's ultimately what's going to be. So X
Switch
down
a
low, switch a row. Yeah, but row doesn't rhyme with row, so.
The rule is four.
I got that. So I'm going to switch these. So now it becomes W is equal to 4.5 over cosine 33. Those of you that were the calculators in the borrowed ones, do 4.5 divided by cosine 33. Borrowed calculator, folks, you do it go backwards. So I'm going to say 4.5 divided by 33 cosine, enter. Everyone needs to practice this. 4.5 divided by 33 cosine, enter.
Point.
Well, don't so just we have people type to it. Because if we shout it out,
Just don't worry.
you didn't hit equal. Now it does. So it is the equal one. So once you have that, you show it. If you did not try this, you don't know if you're getting it wrong or right. So if you did it, you tried it, got it wrong, then we can help you. But you need to try first. So when I do so, W is approximately what? Round to the nearest 10. Again, if you got it incorrect, raise your hand. We'll be around. Gary, what'd you get? 4.5? Should have got 4.5. Oh, the other 5.4. Yes, Gary. 5.4 is your correct answer. 3.7. You might be in the wrong mode. Because you did not divide it. So 4.5 divided by cosine.
I'll do the stuff on my finger.
Okay, if you did not get that, ask now, especially if you're one that borrows our calculator. Yeah, everyone good? Good? That's it. Because it's 4.36 and rounded. Alright, so again, X up high, multiply, X down low, switch a row. Just switch those two. Nice and easy. Questions on those two ways of solving. It doesn't matter which trick you use. Okay, sine, cosine, or tangent. Let's go to this next one. This is the last way to solve. I told you there's only 3 ways to solve. What is different about A and B that's different than the other ones we just did? There's one thing different. Read the question 2. Chloe, what do you think? That what? So all the angles are labeled. Do I have any measurements on those angles? No, so I don't have the certain angles. They're all labeled, they're all marked, but I don't have values. So here's what I'm going to have to do. I'm going to have to find the angle. Whenever I'm asked to find this angle, this is the process you have to do. And you're in luck. Because it's Halloween, this really ties in with the Halloween today. So it says use trigonometric inverses to solve for the angle of x to the nearest tenth of a degree. All right. Well, the process remains the same. Start with your angle. In this case, what angle am I looking for?
Z.
Angle x.
Why are you looking for Z?
Because it says find x.
Oh.
It says find z. It's find z. So I'm starting at my angle. Let's label the sides like we've been doing. Go over here. You know me. OPP. Over here. HYP. Cross the right angle. The last one has to be the ADJ. So we say, what 2 pieces do we have? Gary, what 2 pieces do we have? HYP, exactly right. I got those 2. So which one deals with OPP and HYP? Look back here at your top of your page. Which one deals with O and H? The sine. Sine. So I'm going to do the same process. I'm going to say sine of my angle this time. What's my angle?
X.
X. I don't know that. Is equal to, that's what we're looking for, opposite of our hypotenuse, so it would be 6 over 10. Now notice, x is not the numerator. X is not the denominator. X is the angle. So what do you do here? Well, it'd be nice. You would say, oh, let's divide by sine, right? That's what a lot of you guys would say to get rid of x by itself. I agree. But we can't quite do that with sine. So look at your calculators right now. Everyone look at their calculators. Even if it's a borrowed calculator. Look where sine, cosine, and tangent are. Look at that little blank space right in between them, between the other button.
It's not blank.
It's not blank. There's something there. So look right above the sine. What is written above that sine button?
-1.
It's that -1 thing. That is not a -1, so don't say it. That is saying the sine inverse. That's the opposite. If you look at any of the other buttons, if you look at the part written on the actual calculator, not the button itself, those are the inverses. So this is an inverse function. This is what's going to undo this sine and get rid of it. So I'm going to say sine inverse. Well, if I do sine inverse to one side, I'm going to do it to the other side as well. So I'm also going to have to do sine inverse over here. And that's what happened. These will cancel out. So x will equal sine inverse of 6 over 10. So that's what you guys do with your calculators. Borrow calculator float, do 6 divided by 10, inverse sine, and then you'll have your answer. Again, you have to try this. You just have to work backwards. So x is going to approximately be this degree measure. So if you raise your hand, please, if someone has it, so you have to do 6 divided by 10, and you have to do inverse sine. Morgan? 36.9.
Okay, I got 0, so
36.9 degrees.
16.
I don't know what calculator you're using, Gary, but if so, just do sine inverse, do 6 divided by 10. Now, what is the little phrase to help you memorize this? What helps you memorize this? It's nice and cool. It says, no angle, not a curse. Not a curse, because, you know.
It's Halloween.
Use the inverse.
Wait. What do you mean curse?
I'm just thinking of words that rhyme with inverse, okay? So, no angle, not a curse, use the inverse. So if you don't have the angle, guess what you're going to use?
Inverse.
The inverse. If I don't have the angle up high, I have to. If the angle's down low,
Get down.
switch a row. No angle's not a curse, use the inverse. Like that, Sam? I'm pretty impressed with that.
No, you gotta do like, if an angle's down low, go to the next row.
That's basically stealing mine without the word switch there. But hey, whatever you want to do there. Okay, let's try this next one. So 36.9 is the correct answer. Again, if you're not trying this on your own, you're doing yourself a disservice. So, start the angle. Well, we're finding x again. Label your sides. OPB, HYB, ADJ. Got him. Found him. What two sides do I have values for? Juwan, let's raise your hand. What two sides do I have values for?
What's Joanna? I know what Joanna.
Adjacent and hypotenuse. Very good. So then I got to think, which one deals with adjacent and hypotenuse?
C.
The C.
Not the hat.
This is the cosine. So this is going to be a cosine of the angle. What angle do I have?
You tell me.
X. I don't have the angle. So it's x is equal to the ratio, Juan said, adjacent over hypotenuse,
Maybe what's on the
50 over 20. I have one last step I need to do. I need to do its inverse. Now, I'm not going to use sine inverse on this one. Which one do you think I'm going to use here? Cosine inverse.
Yeah.
That will cancel that out. I'll be left with this. So x will approximately be this. So again, try this out. Work backwards, so you can do 15 divided by 20. And then you're going to do inverse that. Give you guys a second to try this out.
Okay.
Matt, question? Huh? Oh, all for your calculator, you do it straight as you want to do. So you're going to do second cosine, and then type in that fraction. Yes. It depends on what pieces you have. So over here, notice that the sides I have numbers for are opposite hypotenuse, right? So I say, which one of these deals with O and H? Sine does, right? So I would do sine of the angle equals opposite of hypotenuse. Here, after I label the sides, I say, what pieces do I have? I've got adjacent and hypotenuse. See, there's no value for this one? Adjacent over hypotenuse. Which one deals with adjacent over hypotenuse? Cosine.
Hey, ask me the question.
All right. We'll do more. Don't worry about it. It's a lot taken. We'll get there.
Hold on.
And the last thing, when you get it, what is the cosine inverse of 15 over 20? Sam, what'd you get? 41.4. I agree. 41.4. Yeah. Oh, there you go.
Yeah,